Okay, so in this second video, part 2, we're going to be covering conversions that are similar to ones that you covered in activity 3 for the stoichiometry introduction. Now, in that introduction part, you did gram to gram conversions. You went from grams of one compound to grams of another compound. I'm going to do that in the third video. I want to go over another, it's kind of in between. We're going to do 2 problems where we're going to start with grams of a compound or element from this reaction and go to moles of another substance. And then I'm going to do one where we start off with moles of a compound or element and go to grams of a substance. So the first question that I'm going to answer is if you had 13.6 grams of this compound and you wanted to find out how many moles of oxygen, we would go through and we'd start off with the value we're given as always. So 13.6 grams of C4H7O4. And our first step would be to convert this grams. Now, we are always going to do a mole-to-mole conversion in our problems any time that we are going between 2 different compounds. For that reason, we need to have the unit of moles. And if you don't have the unit of moles at the beginning of the problem, the first step that you're going to have to do is to get to that moles. So we're going to look at a periodic table and we're going to determine what's the molar mass of this compound. So if I add up that mass, I find that it's going to weigh 119.11 grams when we add up that formula off of the periodic table. Now, because we added up off of the periodic table, that is going to be equivalent to 1 mole of that compound. And what that does, it allows us to cancel out this unit of grams, and now we have the unit of moles. So now we can go for moles of this compound because we have our coefficients, which are telling us the mole ratio between these 2 substances. So if I can put 4 moles of the compound, C4H7O4, and that's equivalent to 11 moles of O2. That allows us to cancel out the moles of C4H7O4 and leaves us with the unit of moles of O2, oxygen. And that's what we're looking for. How many moles of oxygen do we want? So we're done. All we need to do now is calculate it out. When we do it on the calculator, we get 0.31399. And since we only need 3 significant digits, we're going to chop it off here. So our answer is going to be 0.0314 or 3.14 times 10 to the negative first moles of oxygen. I think we've got room. I'm going to leave this work here and fit the next problem up. So in the next problem, we're going to start with moles in this next problem, and then we're going to go to the unit of grams. So kind of the reverse of this. So if I had 0.46 moles of CO2, and I wanted to know how many grams of water would be produced. So if I make, so in this reaction, if we make 0.46 moles of carbon dioxide, we're going to also make water, and we can determine how much water we're going to make. So again, we're going to start off with the value that we're given, 0.46 moles of CO2. Because we have the unit of moles, we can do the mole-to-mole conversion to convert between the 2 substances. So I'm going to put 8 moles of carbon dioxide from the coefficient, and that's going to be equivalent to 14 moles of water. Now, since the question is asking for how many grams of water, we've got one more step we need to make. And we're going to have 1 mole of water on the bottom, and we're going to have 18.02 grams of water on the top. Now, this value we got by adding up mass of water off the periodic table. And anytime you add the mass up off the periodic table, it's called the molar mass, and that will be the mass in grams for 1 mole of that substance. So that allows us to cancel out everything except for the unit of grams of H2O, which is what we want. Our answer on the calculator ends up being 14.50 grams, but we only need 2 significant digits, so we are going to go through and say, okay, it's going to be 15 or 1.5 times 10 to the first grams of H2O. So here's an example of, there's 2 examples of going between the units of grams and moles. Again, dimensional analysis. You're just finding the conversions that you need based on your balanced equation. You're getting any conversions that involve grams off the periodic table, and you're starting and ending with whatever units you need to start and end with. You just let the dimensional analysis lead you through, and once you get to the unit that you're looking for, stop, do the calculation, get your answer.